Okay, so this is part 2 in my series of analyzing WannaCry. For this part, I'm going to be doing a static analysis, a simple one, which means I'll be looking to see if this piece of malware has been identified by other antivirus providers, hashing the piece of malware to get a footprint of it to see what I analyzed, look for any strings of note that are embedded within the piece of malware, and then do a PE header analysis with the PE Studio software. So first, because VirusTotal is an online service, I did go ahead and kind of cripple the malware by giving it a .bin extension. This isn't 100% foolproof, but it is kind of removing its executable capabilities on the machine by turning it just into a simple binary file. So with that enabled, what I can do is go to Settings, go to Network, and then briefly reattach my network interface to, I'll go with Bridged. Alright, let's see, do we have an internet? Alright, we have Wi-Fi now. Now let's go do something like Chrome. And let's just go to VirusTotal. Now it is a little bit slow. And here you can see that it'll actually go to Chrome because iNetSim isn't handling those DNS requests. It'll actually give us the correct IP address for Google, but it is a little bit slow. Alright. Alright, let's go to Choose File. Nope. This is just like for some reason, some pop-up that occurs when I first installed Flare VM, so it isn't related to the malware. Alright, choose file. There isn't a lot of RAM on this machine, so it is quite slow. Okay, let's go to Downloads and select the bin file. Oh, another one. Alright, it's computing the hash, and let's see what comes up. Now it looks like 68 out of 73 security vendors flag this file as malicious. That means that they have its signature, its behavior, whatever it may do to identify the malware. And it is kind of interesting that Google didn't detect this. Malwarebytes also didn't. Let's just wait. From here you can get a lot of info such as different names that they may have it under. You can see here that the common name is Trojan, WannaCryptor, stuff like that. Go to details, and here we get a list of hashes. That already checks up two of our things. We know that this piece of malware has been identified by other providers, and we have its hashes in MD5, SHA-1, SHA-256, and different other hashing algorithms. We know that it's a Win32exe. It has the PE32 magic numbers, which is MZ. It was likely written, based on this we can identify that it may be packaged piece of malware. And then these are names that it commonly runs under. It is interesting that this disk part, we did see this in the previous step, or in the previous part of this series, where this popped up, but we weren't really sure what it was. This file is not signed, so there's no guarantee of where it came from. Okay, here we can also see the sections of the PE file. You can see that it has a virtual address. Here, because this is useful info, what I'm going to go ahead and do is, because we have this browser in our cache, we can go to Settings, network, and turn our virtual adapter back to host only. And just to verify that, we can just go ahead and Google it for something. Alright, so this machine is isolated again. So this is a lot of useful info that we're going to use for these next parts. So just based on this, I believe we can just click on summary. Okay. Now I believe because we did disconnect from the internet, it was just smaller. We can go ahead and add this to our report. So let's go with the snip. Let me take a screenshot of this. And we can paste that to our reports. Oh, wrong button. So that is the first part to our report. You can see that it was identified on VirusTotal. Next, VirusTotal did this for us, but we can go ahead and look at the hashes that it found. MD5 isn't really secure anymore, but for these next two ones, those are more used, but VirusTotal only gives us a few hash types. So what we can do is we can go ahead and screenshot this. Screenshot. Yeah. And copy that to our hashes. Oh, wrong button again. But there is a tool in Flare VM that allows us to get even more hash types. And that is hash my files. That was a little bit slow. There. And what we can do is take the bin file. Now changing its extension doesn't really change it. So what I was saying is that there is a built-in tool in VirusTotal that allows you to quickly hash your files, and it gives you the hash of it in different algorithms. Now because all we did was just change the extension name to .bin, which changes it into a binary file, that doesn't actually change the code itself. It doesn't change the binary of the file. It's still the same file, just under a different extension. So what we can do is move this here, and we get a long list of different hashing algorithms. Now here we get MD5, I believe. Okay, so we get MD5, SHA-1, CRC232 checksum, SHA-256, SHA-521, SHA-384, and then this is the path on our system where it is. When it was last modified, 2017, which would make sense. That is when the malware first propagated itself. The file size in bits, I believe. Yes, in bits. The version of this executable. The extension, which is .bin. File attributes, AMH. I believe that means that it is a 32-bit file. And then the time it took to hash. Now for a report, what you could do is just copy this and then paste it on here, but because this isn't an in-depth report, we can just go ahead and use the hashes that VirusTotal gave us. And actually we could go ahead and verify that these are the same hashes. Yeah, so like MD5 starts with 84C, same here. And then same with SHA-1. So that is our hashing complete. So what we are going to do next is look through the strings of the piece of malware. Now there are different utilities you can use to do this, but the one I prefer to use is called floss.exe, and you do have to open a command line emulator, which I believe, could I just open it? Let me open a terminal. Oh, I'm sorry, this is the wrong one. Now, what was the name of the one that I used? Maybe we can just do this with the command line. Let's see. Floss. Exe. Alright, that does work. So what we can do is go to our download folder. What we can go ahead and do is go to floss.exe, and then that, and then we can output that to a file named strings.txt. Alright, it's analyzing the program. Alright, I'm going to pause the recording and come back when this finishes. Alright, so that's done analyzing it. So what we can do is just close this. Here we have our strings. We can move this to our desktop. And let's go ahead and open that up. So what did it find? It found here our file path, which seems to be encrypted or encoded. Didn't identify language. It found 43,000 readable strings in ASCII, presumably, and it didn't really find much or anything identifiable. Likely meaning that this program is either packaged or obfuscated, uses some kind of obfuscation technique such as packing or encryption for its function names and stuff like that. So here we found the general names of sections, text, our data, and the resource section. Now just looking at this, it seems like a lot of junk, but there are kind of things that stand out, such as this this F dollar symbol www, which could be used for some kind of website. This kind of looks like basically when you're analyzing the strings, you don't really know what is what at this point. So just look around, and if you see anything that stands out, definitely screenshot it and log it. Here, this looks like something else interesting. This looks like maybe some kind of obfuscated file path, perhaps, because of these percent signs and the backslash, or the front slash. Okay, this looks interesting as well. These look like perhaps keys, because they kind of follow the same format, or these two at least. This one as well, kind of 84896 colon. This would definitely be worth putting down. Here, let me take a screenshot of that. Oh, and look at that. There's also a credit, which this implies to us that this piece of malware likely does some kind of zipping. It probably to unpack itself, or in regards to its encryption functionality, but that is also worth noting. But I believe we got that in our screenshot. Let me just add that. Alright, we did. Okay, and here it looks like there's a list of function Windows 32 calls. Windows 32 API calls, I mean. Okay, so just looking at this, we can get all of these and copy that to another text file, and we can call that Win32 functions. Open that with Notepad and paste that. Alright, that's important. And here it looks like there's a list of imported DLLs or exported. We don't know yet at this point, but that is also worth noting down. Let's also get that. You can name that DLLs. Next, it looks like here we have some function calls, or calls, libc calls, or some kind of function call such as fclose, fwrite, fread, fopen. So we know that this deals with files. Looks like we use some kind of randomization, perhaps in key generation. It looks like we copy memory somewhere. We're dealing with memory based on string copy and memory set. Looks like we get the length of strings or memory. Looks like we do some comparison, perhaps a key comparison to see if the user has paid the ransom. Looks like these are maybe possibly obfuscated function calls. Perhaps these are functions that the malware author created themselves. More of those. That's interesting. There's another DLL here, and one here as well. So we can add that to our list of suspected DLLs, or those are possibly misnamed functions to throw off some kind of analysis. So we can also put that under a suspected list. So we can put this one down, as well as this one. Looks like there's a kernel 32. Now, overall though, we do want to list down these C calls, or these C functions. And I guess we can go up to here. So let's make another file. And we can name this one cfuncs, and copy that. Oh, I'm sorry, I believe it did not copy this. Yeah. Copy that there, and we can save that. Let's close this as well. Save that. Alright, so we got those DLLs. Here there looks to be more, what do you call it? More functions, or Win32 functions that are interesting. Now it looks like these are imported functions such as movefile exw. I believe that ex means that this is a revised version of the movefile function, and now I believe that the movefile ex implies that this is a revised or newer version of movefile, and the w, I believe that implies the word size, which means that this is likely a 32-bit operation. But just to be sure, let me look at my notes. Okay, no. This W implies that it is for wide character strings, which could be Unicode, because those are 2 bytes. The A would imply that it's for ASCII. Okay, so we know that now. Here there's a reference to RSA2, which is an encryption algorithm for asymmetric encryption, which implies that there is some kind of asymmetric encryption enabled on this malware. Now that could be, we did suspect in the previous part that the encryption done by WannaCry is asymmetric encryption, and that once you pay the ransom, they'll send you over the private key to decrypt your files. So that is worth noting as well. Here it is kind of interesting that beyond this kind of like junk that we had up here, this looks kind of formatted because it comes right after these function calls. It is possible that perhaps these are potential functions or instructions, maybe an embedded opcode, so it is worth having that as a screenshot as well. So let me take that as a screenshot. LibreOffice is a little bit weird to work with. Alright. Okay, here is more proof of that encryption functionality. Looks like here we're using Microsoft Enhanced RSA and AES cryptographic provider, and we have some function calls to this cryptographic. We have these cryptographic function calls, and we should include those as well. Here, for these function calls and DLLs and Win32 functions and all that kind of stuff, instead of doing screenshots, I am going to save them as text files. So cryptographic funcs. Let's save this and click save. Now, at this point, we don't know if this piece of malware is packed or not. If it is packed, it's likely that these cryptographic calls are likely just for unpacking the malware. We'll see that. Okay, this is interesting. It's a CMD front/C and then an S string format, or format string. That is interesting. And then here are some, this looks like some kind of encryption as well as more format strings, and then names to executables. Now, because this isn't really something I can label as a category, I am going to go ahead and screenshot that. All right. Oh, it is also worth noting that there is one of those the previous part we saw that on the desktop, a lot of like these b.wannacry, c.wannacry, z.wannacry, a lot of these single letter file names with the WannaCry extension were being generated, and it looks like these are part of the program pre-packing. So assuming that this is a packaged piece of malware, it looks like this T and those other WannaCry single letter files are somehow involved in that packing. Here's something interesting. Look, here it looks like there are some errors, just buffer error, insufficient memory, data error. It is worth putting these down, and this looks kind of like directory traversing based on, or it is interesting. I wonder what that could be. I should put these down though, under a file named errors. Error strings, and just put that down. That could be an error due to its packing functionality or the actual program or the actual malware activity. Looks like more string formats. Alright, just scrolling down, let's see if we see anything else. Okay, here's something. We did see that in the previous part that WannaCry does have multi-language capabilities. This looks like a language pack for Bulgarian, and it is kind of interesting that these single letter .wannacry files are the same extension as the language packs. So I do wonder if these are related, because they are the same. They are the same presumably custom file format. So what we can do in the advanced static analysis is to look at these at the hex level, and maybe see if they are some kind of like encrypted text file, or some kind of just generally some kind of text file format, because this is a language pack, and we do know that this is being at least used before it's unpacked, so it is worth looking at that. We can put that down just like as a general note. Look at WannaCry files, potential language text file formats. Alright, just scrolling down some more. Here's another one for simplified Chinese. traditional Chinese, Croatian. Alright, now this is pretty long, so I'm just going to go a little faster. Alright, just scrolling through this, it looks like a lot of junk. Alright, now we're getting near the end. Okay, it looks like here's more of those language packs. Let's copy that down. We do know that there were those other ones at the top, but because these are all the way at the bottom, they're likely closer in proximity on the actual file. So we can just call this language packs, open that, and paste that. Cancel. Save that, and close this. Okay, so this is interesting. If you remember in the previous part, there were those task.dl and task.se executables that were created after I ran WannaCry on the desktop, and when I tried to run them, nothing happened. So likely, because I believe this is the only reference to some kind of executable, this is what is used for the unpacking of malware, because so far this just looks like a lot of junk, which implies some kind of obfuscation technique, which could be packing. And based on the fact that I believe those are the only two exe files, and then when I try to run them after WannaCry has been installed, when I try to run those two exe files, nothing happens, then I'm led to believe that the only thing they're used for is unpacking WannaCry. So it is worth noting those as well. We can write that as well. Task.dl.exe and task.se.exe are likely related to packing. Okay, this is interesting. Some kind of web assembly. Alright, it is worth copying and pasting both of these. And then also this padding for some reason. I wonder what that could be. Alright, let's write this, or this, let's have this down. Web assembly. Alright, now let's just save that. Alright, flaw static string analysis. So we know that WannaCryptor is the program that is used to encrypt your files, because when we run WannaCry, we get the WannaDecryptor file in our it's like that red box that pops up to ask to inform the user they've been hacked and how to pay the ransom. That was called WannaDecryptor, so we can assume that this WannaCryptor one is the actual file or the actual function that is encrypting the user's files. And then just based on this, looking at this, this is likely a list of key registry extensions, or so I have two guesses of what these two things can be. This is likely either the software that it targets, like when WannaCry is going through your file system, it could be targeting these files particularly to encrypt. We could do some testing on that to see if it's true by giving a file some file extension not listed here, or this could be a list for altering your registry keys, but it is still worth writing it down. We can have that here, and then we can name this list of file extensions. Put that there, save that, and close. Alright, so let's just go through this. And then this just looks like copyright info, which is expected around the PE header. Okay, this is interesting. This part, if we go back to that virus total output, which I believe is right here, let's look for that. So, okay, we can see that the imported DLLs we found, and then the text section. Right. Okay, this part. See, look at that. It looks like that was the original name of this file. It was pretending to be something else, something called disk part. And we can see here that that is in the static string section of the file. Where is it? Right here. So we can just go ahead and copy this as kind of copyright info, as well as the fake name. You know what? It said here in VirusTotal that this was pretending to be Microsoft software. So this could be information to throw off some kind of antivirus or user by providing that fake it is real copyright information, but the malware author put it there to trick the user. So we could put fake copyrights. We can just save that and close. Alright, and then that looks like it's it. Looks like the rest of it is just obfuscated, so there's not much we can do here at this point. We can go ahead and close this. And these are all of the strings of note. So what we can go ahead and do is create a file or a folder, strings, and then just save those to there. Alright, so now we're on to the PE header analysis. Now, VirusTotal actually gives us a little bit of information about that. It gives us the different sections, their virtual addresses, and what is important to us, their virtual size and raw size. Now, what you generally want to look at is differences between the virtual size and the raw size. That'll indicate to you whether a program is packed or not. Now, text. Okay, so now data. Generally, the difference between the raw size and the virtual size is expected. So if here we can see that there's a difference about 2,000 bytes, or 2,000 bits, I believe. It could be bytes or bits, either way. The difference is normal there, that is to be expected. Where we really want to look for differences is the text section, because that is where the actual code is. And it looks like here that there aren't really any differences in the code, which is interesting. There aren't really any differences in the size of the raw size and the virtual size. So either this isn't a packed piece of malware, or it is using some kind of advanced technique to obfuscate that. And considering this is kind of an old malware, I'm going to go ahead and assume that potentially it isn't packed, or the sample that I downloaded was unpacked before being uploaded to the internet. We're going to have to do a more advanced, or do a PE header analysis to determine that. And here we can see a list of, okay, look at that. It looks like those imported functions that we found earlier are that list of kernels, that list of DLLs was used for importing, and it makes references to different imported functions for the kernel 32 DLL, such as create directory W, create file, create process. So we can tell that, based on this, we can tell that the malware is doing some kind of file and directory altering, as well as creating processes. WSPrintFA, I believe that is just some kind of standard output function. Here it looks like, okay, API 32. Based on this, we can also now learn that the piece of malware alters our registry keys. That could be to set up some kind of persistence or other malicious activities. But mainly likely is to prevent the user from deleting WannaCry from their system by altering those registry keys. And then MSV cert DLL. See, we did suspect that those like weird strings are potentially obfuscated function calls, and based on this, I believe that it seems to be the case. This could either be a malicious DLL, or the programmer just obfuscated the names of the functions. So that is useful for us. We can go ahead and save that. This more. Oh, this is way more. Let's for this as well. Alright, let's go ahead and save this. And let us make a file, DLLs, imports. Let's save that. Now there were more than that, only listed 4 DLLs, but if you remember, there were a lot more than 4. I believe here. Yeah, so these were the DLLs that were listed on VirusTotal, but there are different ones like Shell32, Alia32, WS232. So it is worth looking at those as well. Alright, now what we can do is run the malware binary through a PE header analyzer. That'll tell us different info such as imported, exported libraries, maybe WannaCry has its own custom DLLs for DLL injection, or maybe it uses its own custom functions that it wants to store in a DLL for some reason. What we can go ahead and do is use PE Studio. Now let's open that. Go to File, Open. And store this here. Now this is going to take a while, but for now we can just look at the info we have. Okay, so this does tell us the first few bytes of the file. If you were going to write a yarn rule, you could include this, although because most PE32 executables start the same, this isn't really that useful. Okay, so here we have the size of it, which is listed as 3,514,368 bytes. That is kind of a small number, so potentially that is more evidence that it was packed, but at the same time, those section sizes weren't really that different, specifically for the text section. So although I do suspect it is packed, the evidence is pointing to it not being packed. Alright, so it was originally listed as disk part, and then this is the entry point. This does look kind of like a typical CDECL calling convention entry point, like the 55. The 8B, it is kind of how it works when you like push EB or push EBP, push ESP, sub ESP, EBP, stuff like that. It does kind of look like a typical function call. So that probably wouldn't be too useful for a yarn rule. Right, it looks like the compiler stamp, likely this was compiled in 2010. It was kind of an old piece of malware. It did use leaked NSA exploits that could point to potentially an old date of when it was created, although this can be spoofed, so take that kind of with a grain of salt. So nothing here, nothing much here. Okay, let's look under DOS header. Now this is kind of a old piece of technology. The DOS header is kind of useless nowadays, so nothing really worth looking at there. What about directories? Okay, so I can't really check the import table for the DLLs and the resources. I guess I'm gonna have to wait on those. Okay, this is that thing we found earlier, this manifest file. Okay, so it looks like this is the manifest file that is on the executable. And we did find that earlier. We presume that this was some kind of WebAssembly, but it turns out it is just a manifest file. And version, just general copyright info. That was the info we found all the way at the bottom, though. So that does tell us that that's not copyright info. This is actually just version information. Because we got, yeah. Or I guess it is kind of copyright info. It tells us like Microsoft Windows OS, the product version, then product name, file version, stuff like that. So that could be faked, but it's good to know that that's what that is. Alright, so I guess there's not really much we can do but wait on this. So I'm going to pause the recording, and then when this finishes, I'll come back. Now, unfortunately, PE Studio is being really slow on this machine. I have had this issue before, so what I'm going to go ahead and do is instead use Dependency Walker to get an idea of those DLLs that are being used. So let's go to Downloads. It should be under, where is this PC? Here, Downloads. And then import this, and this should give us an idea of the DLLs that are being imported or exported. Now that's going to take a while as well, so I will pause the recording. Okay, unfortunately, it looks like my machine is a little bit too weak to be running this kind of stuff, so what I'm going to go ahead and do is hopefully not crash the machine, because I do want to keep those strings that I exported, but we really got all the information that we need. We got an idea of the strings that are in the file. We found that this is likely not an imported or a packaged binary because of that text size being correct. So at the moment, oh, and we also do have that list of DLLs, which tells us likely the functionality of the program. It uses cryptographic functions. It messes with directories and files. It creates and alters them. It creates a mutex, that's also worth noting. It creates it works with threads because of this mutex call here. What else does it do? It locks resources. It uses cryptographic functions. Alright, so I'm sorry, I wanted to go do something. Now, based on the cryptographic functions called, the registry functions called, and these kind of obfuscated function names from the DLL. Oh, and these mutex, meaning it works with threads, the file pointers, the directory, the directory traversing, memory allocation, file altering. We can assume that. Okay, we have a general idea of what this code is doing. And really that's all the information we're attempting to get out of a static analysis. So I believe that really we're kind of done. While we didn't really get to look at our more in depth on the PE Studio, the main purpose of the PE header analysis is to get an idea of the DLLs that are being imported and exported potentially by looking at that DLL table. But because we found already a lot of DLLs in strings and from VirusTotal, we got most of the info that we would have gotten anyways. Now, because this does seem... okay, it looks like we got some info. Oh no, we already had this. Okay, because this is going to take a while, what I will do in future videos is to preload this so that, because I know it does work eventually, but it does take quite a while. It takes like 20 minutes. I don't know why it is so slow when on other tools that don't give as much information or more assembly based, like a PE Bear. They will load a little bit quicker. I don't know what the issue with PE Studio could be, but generally I think that this is a successful static analysis, and what I'll do next in the next part is to do a dynamic analysis, which will involve me setting up the virtual or the fake network again with inetsim, and then setting up different process monitoring tools such as procmon, wireshark, process explorer, and different stuff like that. Alright, well, I'll go ahead and export this to my personal file. I guess personal computer. I guess what you could go ahead and do is turn off PE Studio, I guess, because this may be vulnerable. And then, where is the, where do you call it? Oh, I'm sorry. You're going to want to go to the WannaCry.zip and the executable itself, and just delete those. You already have, presumably you've already backed up your machine. So we can just go ahead and delete those, send those to the recycling bin. And now their indexes are gone. I assume this is xfat or fat32, something like that. Those files still do exist in the system, but aren't really an issue now. So what we can go ahead and do is zip this. Oh, I'm sorry, I meant to zip. Add to archive. We can just call it. I'm sorry, no, I keep clicking the wrong stuff. We can save this to app.zip, and we have the zip file here. Let's just look at it. Right, it has all our static analysis info. And then what we can do is go to settings. Then you can just enable your network again. You didn't really run it. The malware in this case, because it is just a static analysis, so you are safe to connect. You are very likely to be safe connecting to the internet again. You can go ahead and just connect to the internet and then upload it to some file sharing site. The one I like to use is file.io. It is anonymous, and there is a high maximum for uploading files. You can set it to delete after a few minutes or an hour, whatever time you need, and then that's really it. You can just download that from your more secure computer. What I like to do is download it from my Debian machine. This laptop is only for malware analysis, but I do have a more general one for schoolwork, stuff like that. I'll download it to that. I'll run scans on it. I'll look at its binary to make sure there isn't any embedded executable or some kind of worm that could have attached to it. And from there, I can go ahead and upload it to my GitHub. So I'll do that off screen, and then I'll release the third part, which is the simple dynamic analysis. So thank you for watching.